K-means clustering is an unsupervised machine learning algorithm used to group similar data points into clusters. It works by iteratively refining cluster centers to minimize the variance within clusters. Imagine you have a bunch of colorful candies, and you want to sort them into groups based on their colors. K-means helps us do that. In K-means, the letter K is like the number of groups we want to make. For example, if K is 3, we will sort our candies into 3 groups. WCSS, or within cluster sum of squares, is a measure of how well the clusters are formed. It calculates the total squared distance of each point from its assigned centroid. The lower the WCSS, the more compact and well-defined the clusters are. We use WCSS to evaluate clustering quality and decide the best number of clusters. WCSS is a fancy way to measure how close the candies are to the center of their group. The K-means algorithm follows an iterative process. First, it selects random centroids, then assigns each data point to the nearest centroid. Next, it recalculates the centroids as the mean of all assigned points. The Euclidean distance formula, given by d equals the square root of the sum of squared differences between coordinates, is used to measure the closeness of data points to centroids. This process continues until centroids no longer change significantly. The elbow method is a technique used to determine the optimal number of clusters in K-means clustering. It works by plotting the number of clusters against the within cluster sum of squares, or WCSS. As we increase the number of clusters, the WCSS decreases because the points are closer to their centroids. However, after a certain point, adding more clusters doesn't significantly reduce WCSS. To find the best number of clusters, we plot this graph. On the x-axis, we have the number of clusters, and on the y-axis, we have WCSS. The best number of clusters is found at the elbow of the graph. This is where the curve starts to level off, meaning adding more clusters doesn't improve the results significantly. Step 1. Choose the number of clusters, denoted as K. The value of K is determined using methods such as the elbow method or the silhouette score. Step 2. Initialize K random centroids. These are the initial cluster centers, which will be refined in the following iterations. Step 3. Generate random data points. These points will be grouped into clusters based on their proximity to the centroids. Step 4. Assign each data point to the nearest centroid. The distance between a point and a centroid is calculated using the Euclidean distance formula. Update the centroids by computing the mean of all points assigned to each cluster. The new centroid is calculated using the formula Cj equals 1 divided by the number of points in cluster Cj, multiplied by the sum of all points in that cluster. Repeat the assignment and update steps until the centroids stop changing significantly or a maximum number of iterations is reached. The algorithm converges, and the final clusters are formed. Each cluster is represented by a distinct color. And that's how k-means clustering works. K-means clustering effectively groups data based on similarity. It minimizes the within-cluster variance, making it a powerful tool for clustering tasks. Let's explore the advantages and disadvantages of k-means clustering, a popular algorithm for grouping data. K-means is simple, fast, and scalable. It works well with spherical clusters and allows you to choose the number of clusters using methods like the elbow method. However, k-means has some limitations. It requires you to specify the number of clusters in advance, is sensitive to initialization, and struggles with non-spherical clusters, outliers, and complex shapes. Use k-means when your clusters are well separated and spherical. You have a large dataset, and you are okay with specifying the number of clusters in advance. Avoid using k-means when clusters are not spherical. There are many outliers, or the data has complex, nonlinear boundaries. K-means is a powerful tool for clustering, but it has its limitations. Choose the right algorithm based on your data and problem. K-means clustering is a versatile algorithm used in many real-world applications. It groups similar data points into clusters, making it useful for tasks like customer segmentation, image compression, and more. One of the most common applications of K-means is customer segmentation. Businesses use it to group customers based on their purchasing behavior, demographics, or preferences. This helps in targeted marketing and personalized services. K-means is also used in image compression. It reduces the number of colors in an image by grouping similar pixel colors into clusters. This makes the image file smaller without losing much quality. K-means is widely used in document clustering. It groups similar documents together based on their content, making it easier to organize and retrieve information. This is useful in search engines and recommendation systems. K-means is also used for anomaly detection. It identifies unusual data points that do not belong to any cluster, which can indicate fraud, network intrusions, or system failures. K-means is used in market segmentation to group customers based on their preferences and behaviors. This helps businesses tailor their products and marketing strategies to specific customer groups. K-means clustering is a powerful tool for grouping data in various fields. From customer segmentation to anomaly detection, it helps us make sense of complex data and derive meaningful insights. I hope you found this video helpful. If you enjoyed it, please give it a thumbs up, subscribe to the channel, leave a comment, and share it with your friends. Your support means a lot. See you in the next video.